Hello students, welcome to part 2. So in this video, we are going to be reading textbook pages 92 until 94 and then completing or going over the answers for workbook page 65. So you can definitely skip the reading part of this video if you would rather read alone. And before you watch the part where we go over the answers for page 65, make sure that you give it your best and try to answer these questions individually first. Okay? I believe in you. Let's go ahead and start reading. Matter and thermal energy. You already know of ways that changes in thermal energy affect you and the things around you. If you wait too long to eat hot food, it cools off. If you do not eat your ice cream quickly enough, it melts. A fire burning in a fireplace warms the air in the room. All of these situations involve the flow of thermal energy. State changes. The moving particles in matter attract each other much as magnets attract each other. The amount of attraction can vary though. It depends on the speed at which the particles move. As the temperature of a substance increases, the speed of its particles also increases. As the particles move faster, there is less attraction between them. Particles in a solid do not move very much. They just vibrate back and forth. Because their small vibrations do not force the particles very far apart, the attraction between the particles is great. In a liquid, the particles move a little faster and there is less attraction, so they're further apart. Particles in a gas move rapidly and cover great distance. There is little attraction between the particles, so see how they're far apart? They're not very attracted to each other. As a substance is heated up, it gains thermal energy, and this additional energy causes the particles to move faster and to move further apart. When they're further apart, they have less attraction. A solid may become a liquid, or a liquid may become a gas. And if a substance is cooled, the opposite will occur. It loses thermal energy and may change to a state of matter in which the particles move less and are attracted to each other more. For example, when the gas inside a refrigerator cools, it changes from a gas to a liquid. So as you add thermal energy, as it gets hotter, a solid will go from a liquid and a liquid will turn into a gas. But if you take away the thermal energy, the gas will go to a liquid and liquid into a solid. Now, thermal expansion. So this is an example of the spaces between the structures. So spaces between sections of this bridge allow the sections to either expand or contract without breaking. Engineering. Sometimes when the temperature change is not very great, a substance does not change its state. So states are here, solid, liquid, gas. The substance's particles may only move faster and occupy larger space. This property is known as thermal expansion. A liquid thermometer uses thermal expansion to measure temperatures. When thermal energy is added to the liquid in the thermometer, it increases the speed of the liquid's particles, and the liquid in the thermometer expands and takes up more space. And this increased volume causes the liquid to show an increased temperature on the thermometer scale. The reverse or the opposite is also true. When a substance is cooled down, the particles move less rapidly and occupy less space. In this case, the substance shrinks or contracts. Almost every substance expands when it's heated and contracts when it's cooled. When the temperature of most substances changes only a little bit, they expand or contract only a little amount. However, even a small amount could cause great problems. Engineers must allow room for these small changes in size as they plan structures. If you look at a bridge, sidewalk, or highway, you may see spaces between the sections. These spaces allow the structures to expand and contract without buckling or cracking. Mini science experiment if you want to try this at home. If you have two spare balloons, you can actually see thermal expansion for yourself. So you're going to blow up the two balloons halfway, so not all the way. Put one of them in the refrigerator or the freezer, so you're going to take away thermal energy, and then put the other balloon inside somewhere hot or warm, like in a hot, heated bathroom maybe, and then try to see the differences. And what should happen is that in the balloon in the freezer, it should actually shrink because you're taking away the thermal energy, and the balloon in the warm area should expand because you're adding thermal energy. If you actually end up doing this, definitely tell us about it during Zoom on Friday. Measuring thermal energy. Since thermal energy and temperature are not the same, they're not measured the same way. One of the units used for measuring thermal energy is a calorie. A calorie is the amount of thermal energy that's needed in order to raise the temperature of 1 gram of water by 1 degree Celsius. Raising the temperature of 10 degrees of water by 1 degree Celsius takes 10 calories of thermal energy. It also takes 10 calories to raise 1 gram of water 10 degrees Celsius. The amount of thermal energy therefore required that would actually depend on both the mass of the substance as well as the change of temperature. Stored thermal energy. Some substances heat or cool more easily than others do. This means that the substances have different abilities to store thermal energy. Perhaps you've noticed in the summer the metal parts of a bicycle get hotter than the plastic parts do. Metals can store a lot of thermal energy. Even just a little heat will make them warm up, like the hot seat belt in a summer day. But plastics do not store as much thermal energy, and it takes a lot of heat to warm it up. That's why if you see like a bicycle, we have those handles, and the metal is usually covered by the plastic grips to protect your hand, and so you don't burn your hand by the metal handles. All right, page 65, study guide. Pause the video, complete the questions on your own, and then resume. Okay, so this is going to be reviewing some of the concepts we were going over even before today. So stored energy, or energy that an object has because of its position, is called potential energy. So all of these we went over in the PowerPoint as well. So potential energy. Energy that an object has because of its motion is the kinetic energy. Okay. The total kinetic energy of the particles in the substance is called thermal energy. The measure of the average kinetic energy of the particles in a substance is called, so the measuring of it is the temperature, okay? Number 5, thermal energy is measured in calories. And number 6, temperature is measured with a thermometer. Fantastic job, guys. I will see you next time.